Happy Monday, third grade. Oh, wait. We just had a really long weekend. Sorry. Happy Tuesday? Yeah, Tuesday. Okay. I don't know. This is Mrs. Jaggs, and I'm teaching science, so things are just really crazy this week. But this is our land and water unit, and I have a question for you today. How does nature change the direction and flow of rivers? Did you ever think about it? Well, think about this. The first American woman in space was Sally Ride. Pretty cool last name, huh? Since she rode up into space. And in honor of her special day, it is National Paper Airplane Day. So hopefully the weather's beautiful outside for you to construct your own paper airplane and let it fly in the sky, just like Sally Ride. Today's game plan, we're going to be reviewing some definitions and learn how exactly nature changes the direction and flow of rivers. We're going to check our understanding to make sure that we actually get it, and then we're going to wrap up what we did today. Okay, so some definitions. You'll see 3 pictures of rivers there. Even though they're labeled streams, streams are smaller versions of rivers. Rivers are large moving streams of fresh water that drain off the nearby land and flow towards the sea. So they can be meandering or curving. They could be straight and kind of branch out into tributaries, or they could be braided, where it looks like several streams are kind of flowing in and out of each other. And then to review, we have erosion. It's the gradual destruction of something by wind, water, or other natural processes. And deposition is a process in which sediments, soil, and rocks are actually added or deposited to a landform or landmass. So what do you think happened to this river? Looks pretty strange, right? Well, these rivers actually exist all around the world.
Compared to the whitewater streams that tumble down mountainsides, the meandering rivers of the plains may seem tame and lazy. But mountain streams are corralled by the steep walled valleys they carve. Their courses are literally set in stone. Out on the open plains, those stony walls give way to soft soil, allowing rivers to shift their banks and set their own ever-changing courses to the sea, courses that almost never run straight. At least not for long, because all it takes to turn a straight stretch of river into a bendy one is a little disturbance and a lot of time. And in nature, there's plenty of both. Say, for example, that a muskrat burrows herself a den in one bank of a stream. Her tunnels make for a cozy home, but they also weaken the bank, which eventually begins to crumble and slump into the stream. Water rushes into the newly formed hollow, sweeping away loose dirt and making the hollow even hollower, which lets the water rush a little faster and sweep away a little more dirt, and so on and so on. As more of the stream's flow is diverted into the deepening hole on one bank and away from the other side of the channel, the flow there weakens and slows. And since slow-moving water can't carry the sand-sized particles that fast-moving water can, the dirt drops to the bottom and builds up to make the water there even shallower and slower, and then keeps accumulating until it becomes new land on the inside bank. Meanwhile, the fast-moving water near the outside bank sweeps out of the curve with enough momentum to carry it across the channel and slam it into the other side, where it starts to carve another curve, and then another, and then another, and then another. The wider the stream, the longer it takes the slingshotting current to reach the other side, and the greater the downstream distance to the next curve. In fact, measurements of meandering streams all over the world reveal a strikingly regular pattern. The length of one S-shaped meander tends to be about 6 times the width of the channel. So little tiny meandering streams tend to look just like miniature versions of their bigger relatives. As long as nothing gets in the way of a river's meandering, its curves will continue to grow curvier and curvier until they loop around and bumble into themselves. When that happens, the river's channel follows the straighter path downhill, leaving behind a crescent-shaped remnant called an oxbow lake.
Or a billabong.
O un lago en herradura.
Ou un bras mort.
We have lots of names for these lakes, since they can occur pretty much anywhere liquid flows, or used to. Which brings up an interesting question. What do the Martians call them?
So where is erosion happening in this river? Is it A, outside the bend of the curve, or B, inside the bend of the curve? Look at the pictures carefully. What do the blue parts represent? What do the tan parts represent? Where is deposition happening in this river? Your answer should be the opposite of what you had for the erosion answer. So does deposition occur outside the bend of the curve or inside the bend of the curve? Remember, deposition occurs when rivers actually change shape because of erosion and deposition. When parts of river curves are eroded away, they settle somewhere else, sometimes making a new shore of the same river. So there you can see the deposition of the new material and the erosion of the riverbank.
The world is divided into two kinds of people, those with innie belly buttons and those with outies. Rivers also have innies and outies, not belly buttons but mouths. Where rivers flow into the sea, the land either pokes out or bends inward. But rivers don't have umbilical cords, so why do they have innies and outies? Well, coasts are the front lines between two opposing forces, land and water. In order for the ocean to invade the land, sea level either has to come up or the land has to sink down or be eroded away. And in order for the land to advance into the ocean, sea level either has to drop or the land has to build or be lifted up. Obviously, if sea level drops and then rises back again, there's no net gain on either side. But things get more complicated when a river joins the battle. For example, during the last ice age, sea levels fell by over 120 meters, and rivers cut deeper and deeper valleys to reach the falling seas. Then, about 18,000 years ago, warming temperatures began to melt the ice, and the now rising seas flooded river valleys around the world, creating giant estuaries and giving us the innie-riddled coastlines we have today. But when the steady landward march of the seas finally began to slow about 7,000 years ago, the coastlines around the mouths of some rivers began to gain back some ground. The key factor was the sediments that rivers drop as their currents slow at the entrance to the sea. Where the sediment supply was big enough and the ocean was calm enough, the dropped dirt piled up, eventually forming new land that both lengthened the river and divided it in two. Dirt would continue to drop out and build up at the mouths of both channels, splitting the river again and again and again, creating a new lobe of land advancing slowly into the sea. Thus, the world's great outie river mouths, the fertile deltas like the Nile and the Yangtze that have helped foster human civilization since its birth, all came into being at just about the same time. The same can't be said for all of the world's outie belly buttons. What can be said, though, is that innies and outies, for both rivers and people, are a small record of how we came to be.
Kind of weird to think of rivers having innies and outies. So which river below has an innie river mouth? Is it the top river picture or the bottom river picture? Another word for an innie river mouth is estuary. What two factors must a river have to form a delta? The delta is formed below. You can see where the red arrow is pointing. Look at the picture for a clue. All right, let's wrap it up for today. We learned that nature changes the direction and flow of rivers through erosion, the wearing away of the land, and deposition, the collection of rocks and materials into a new place. We also learned that coastlines are the battlegrounds between land and water that create estuaries, which are like the innie belly buttons, and the deltas, which are the outies. So the next time you see a river, look for that deposition and that erosion and see if you could find out if it has an innie or an outie. Have a great day.